Hello guys, welcome back to class. In this session, we'll start a new module, new topic in the second module, that is operators. So what an operator does, what is the task of an operator? Operators. Operator performs operation on operands. So here we have to learn what is the operator, what are the operators available, and for each operator, what is the operation it is performing, and what are the operands allowed. You can use another to give a result. And what is the result it is producing? What is the result it is producing? Like, if you take a small case, all of you know about a plus operator. So this is an operator, plus is an operator. What is the purpose of this operator? Purpose is to find the arithmetic sum. First, you should know the purpose of the operator. Yes, this is to find arithmetic sum. Okay. Next, for this, what are the operands allowed? Operands means when you want to do arithmetic sum, how many values you need? How many values you need? You need two values, right? 10 and 20. We can't only write 10 plus, right? So this is not valid. It means plus needs two operands. So this is called as operand 1. This is called as operand 2. How many operands required for this? Two operands. Not minimum two only. Exactly two operands required. Only two operands only required. 0, 1 not allowed, 3 not allowed. Is a two operands called as binary operator. And plus is the operator. Plus is the operator. Now, how many operands? Two operands. Next, what is the type of operands allowed? What type I can take? This is number. This is number. Numbers. For example, I have a hello class object. Hello H is there. Hello H1. Hello H2. Can I say H1 plus H2? Here H1 is of type hello. H2 is of type hello. Not allowed. These operand types are not allowed. Right? So how many operands allowed? What is the type of operand allowed? Only specific allowed. So what are allowed? We have to learn. Then what will be the result of this? What's the result of this? Result also will come as a number only. Result also will come as a number only. So here in this number, again, it can be an integer, it can be a byte, it can be a short, it can be a long, it can be a float, it can be a double. So what will be the type of result coming up? So when you're learning the operators, these are the important things. Finally, result type. So I'll just make one small table to understand this. So when you're learning an operator, what you have to learn? First is purpose of operator. Purpose of operator you have to learn. Next. Number 2, operands allowed. Operands allowed. In this, how many operands allowed? And type of operands allowed. How many operands and type of operands. Number 3, result of operation. Result type is a result type, a type of result. You call it as type of result. About each operator, you have to learn these things. Right? So we'll take first plus. If I do A plus B, plus operator we are talking. For a plus operator, purpose is to find a arithmetic sum. Okay. Operands allowed. For a plus is a binary operator. So 2 operands allowed. And what is the type of operands allowed? Type, you can use 6 number types, plus even char also can be used. We have primitives, right? 8 primitives are there. Only Boolean not allowed. Boolean type not allowed. Means we can't say 10 plus true. 10 plus true not possible, guys. 10 is a number, say integer, and true is a Boolean. For a plus operator, one side is number, means second side Boolean is not at all allowed. Boolean is not in a number family. So we can't do that. So Boolean is not allowed. Number types you can use. 6 number types: byte, short, int, long, float, double. 6 number types, plus even char also we can use. What should be the result? Result is always, so int or higher than int. Higher than int. This is the important thing to learn. Int or higher than int. We'll talk about this later. So finally it is giving a number. Result is number only coming, right? So I will use another operator, A greater than B, for example. When I use A greater than B, guys, what's the purpose of greater than? What's the purpose of greater than? Comparing, right? It is comparing, comparison operator it is. Comparison, compare, okay. For this, how many operands required? How many operands required? For this also 2 only. 2 only, Monica. It is also binary. We can't say A greater than. Can you say only A greater than? A greater than, no meaning, right? So 2 operands required. Then what is allowed? What operands allowed? For this, you can use again 6 number types plus char only allowed. And what should be the result of this? Result of this, if you write say 10 greater than 20, what will come finally? You will get a Boolean value, either true or false, right? So result is Boolean. This is important. Result finding is very important, guys. Same, you are using operator plus number plus number. Result coming as a number. Number greater than number. Greater than is giving a Boolean type as result value. Maybe true or false depending on your AB values. Right? One more I'll take. Suppose I'm using plus A. So what do you say? This is for increment by 1, right? Purpose of this operator is increment by 1. For this, how many operands allowed? How many operands allowed, guys? Very good. Only 1 for this. This is called as unary operator. Only 1 operand is more than enough. And what operands allowed? Type of operand. Type of operand is again the numbers, 6 numbers plus char. Only allowed. 6 numbers plus char only. And result comes as again a int or higher than int. Right? This is the high level I am showing. So we have so many operators, around 30 plus operators we have in overall we have a 30 plus operators in Java under various categories. Like we have arithmetic operators, relational, logical, bitwise, increment, decrement operators, assignment operators, right? Compound assignment operators, multiple are there. Under all the categories, we have overall 30 plus operators. About each operator, what you have to learn is these things you have to learn, right? So what to learn is clear. So can we start learning the operators now? So depending on the number of operands, we can categorize the operators into three types. I have a small notes to open. Let it to. This is module 2, guys, part 3, right? Module 2, part 3. Okay. See, operators are used to perform some operational operands. Okay. Now, depending on the operands, depending on the number of operands you are using, there are three types of operators: unary operators, binary operators, and ternary operators. Unary operators means requires only one operand. Like we have seen, plus plus is an increment operator which needs one operand only. Minus minus needs one operand only. Like this, some operators are there which needs one operand. And most of the operators are binary. Binary operators means requires two operands. And ternary operator requires three operands. We have only one operator in Java, only one operator. Conditional operator is the one operator which is the ternary. And very less unary operators are there. Most of the operators are the binary operators only. Okay. So when you're learning operator, first you have to understand whether the operator is unary or a binary or ternary. Depending on that, we will decide the number of operands required. Next, what are the type allowed? What is the result comes? The three types depending on the operators required. Either two operators, binary operator. Three operators, three operands, ternary operator. One operand, unary operator. Depending on the operation you are performing, your operators are like this. They are the list of operators. Number one, arithmetic operators. Arithmetic again two categories, unary and binary. And second, string concatenation, assignment, compound assignment. Assignment again two categories, simple and compound assignment. Increment, decrement, relational, logical, and new operator, instance of operator, conditional or ternary operator, which is the only one operator needs the three operands. And the last, the bitwise operators. Okay. So these are 10 categories: bitwise, conditional, instance of new operator, logical, relational, increment, decrement, assignment, string concatenation, arithmetic. These all, if you count, these are 5 operators, 1, 6, 7, like this. If you count all these little operators, overall we have 30 plus operators. These 30 plus operators we have to study now one by one. So clear? We'll start with the arithmetic operators first. Arithmetic, two categories we have: unary and binary operators. Okay, let's start with arithmetic operators now. Arithmetic operators, shortly I'm calling AO, arithmetic operators. In arithmetic, we have seen two categories. One is unary arithmetic operators. Second category is binary arithmetic operators. What are binary? First tell me the binary arithmetic operators. Binary plus, minus, star, division, modulo. Only 5 are there. There are 5 binary arithmetic operators. 5 binary arithmetic operators. And no need to explain this purpose, right? You know, from childhood you are learning about this. Unary, there are 2 unary arithmetic operators. Plus, minus are called as unary operators also. The 2 unary and 5 binary arithmetic operators we have. Okay. So first we'll start with unary arithmetic. So these are arithmetic operators. Plus is an arithmetic operator. Minus is an arithmetic operator. But how it is unary? Unary means we need a one operand. How plus becomes the unary one operand? It is a 1 plus I am talking, guys. For example, Naveen told a plus equals to 10. This is not a single operator. This is plus equals is called as compound assignment. And Navanitha told plus plus. This is again a plus plus is a one operator. One operator. Plus plus is not 2 operators, is a one operator. Its goal is different. We are not talking about increment decrement operators now. Understand? Increment decrement is our category. You see my table, guys. You see my table. See here. Under third category, assignment operators, we have a plus equals. Plus equals is a combination of single operator. Minus equals, star. These are a compound assignment operators. We'll talk later. We are not talking about that. Similarly, increment, plus plus, minus minus are the increment decrement operators. Now we are not talking about that. My question is only plus, just plus. Now listen the question carefully. How plus is unary operator? Only plus. How unary operator it is? If you want to add a 2 values, Monica, we need, it is a binary, right? This side you take. Second side you take. Plus binary operator. Plus binary means you say 10 plus 20. We need 2 to add a sum. Minus you take 20 minus 10. Star you take 10 into 2. These are all binary operators. These are all binary. How binary? It needs the 2 operands. Subtraction also need 2 operands. Multiplication need 2 operands. Division need 2 operands. Modular need 2 operands. How single it is? Yeah, Alaikia and Govardhan. You got the point now. Plus and minus. Very good, Naveen. Plus and minus you are using to represent a sign. Very good, guys. This very small point, but you have to get that strike on the way. So what is this unary arithmetic? These are to represent a sign, positive or negative. Positive or negative. You will represent, right? You have to represent a number as a positive or negative. Yes, that case, to represent a positive number, you are writing plus 27. So how many operands you are using here? How many operands, guys? One only. That's what plus is. When a plus is used as unary operator, it is used to specify the positive number. Minus 27. This is, again, I am using a one operand, 27, single operand. It may be a variable also. Plus A minus B, something like this. So these are the examples of unary. In this, what you are doing, guys, to representing positive or negative number. So unary operators clear? Arithmetic unary, how many are there? Only 2 are there. Plus and minus. Plus is used to represent positive numbers. Plus one value only you are writing. Minus single value to represent a negative number. Coming to the arithmetic operators, which are binary. What's the purpose of the binary? These are to perform arithmetic operation. Arithmetic operations are clear, right? addition, subtraction, multiplication, division, and remainder calculation. These are the mathematical or arithmetic. You can also use arithmetic only. This basic addition, multiplication are called as arithmetic operations, right? And these are all needs two operands. These are all needs two operands. 10 plus 20, 20 minus 10, 10 by 2, 10 into 2, 9 module 3, something like this. These are all two operands required. But important is, so you know the operator, you know the how many operands allowed, right? And how many operands this side, unary side, one operand. Next, what you have to learn, you know the purpose, you know the number of operands. Type of operand allowed. Next you have to learn is type. What type of operand allowed here, guys? This is very important, remember. Type is 6 number types. You can use, first time I am writing byte, short, int, long. 4 integers, 2 floating point, say float and double. Total number type, how many are there? 6 number type, and char also allowed. Only these 7 types, 6 number plus char. Remember like that always. What type allowed? 6 number plus char. Now, according to this, you tell me whether this is okay. Can I say minus true? Minus true, guys? No. So, Boolean operand is not allowed for this. Okay, come this side. This side, arithmetic, binary arithmetic operators. In the binary arithmetic also, the type allowed is, again I am writing 6 number types. What are 6 number types? 6 number types are byte, short, int, long, float, double. Remember, always I'll use 6 number types and 1 char type only allowed. These 7 types only allowed for the arithmetic operators. So can I use a true plus 10? Can I use a true plus 10? No, guys, Boolean is not in this game. Arithmetic operators, anywhere we don't have a Boolean option. Only 6 number types plus char allowed. Now, what will be the result? The last you have to learn is result, guys. See the previous table I have shown. What you have to learn? You know the purpose, you know how many operands allowed and type of operands allowed, a result of the expression. So, what will be the result? 10 plus 10. Here the result is, remember this, result is int r higher than int. This is very, very important point to remember. Result is why int are higher than int. We'll elaborate this particular point. Take the next page. So what's the point to elaborate here? Result of arithmetic operator is int or higher than int. This is only main thing you have to learn. Plus means addition, minus, subtraction, that you studied maybe in your first standard only, right? This is the important thing. Int or higher than int. Okay? In this, Boolean anyway will not come at all, right? Boolean ignore. Other than Boolean, how many types are there? 7 types are there. You see in that which is a smaller, which is a higher. Which is a smaller, guys? Which is a smaller? Among all the number types, which is a smaller? Byte is a smaller, right? Byte is a smaller. What is the higher than byte? Higher than byte is a short. Higher than short, int. Higher than int, long. Higher than long, float actually. You may get confused on this, but remember it is a float only. Because why you will get confused is long is the 8 bytes, right? Float is the 4 bytes. But why you say then float is the higher than long? Because of the float having a precision, that will be considered always as the higher only. Because of the precision, decimal points are there, decimal point representations in the hierarchy, float is considered as higher than int. Even though float has a less type, remember it, even though it has plus type. Okay, and now higher than float is the double. Higher than double, guys, nothing is there. Currently, nothing is there. Fine. And one more, we have a char type. Char, higher than char means integer, because char and short are same, right? So byte, higher than byte is a short, higher than short is a int. Char, higher than char is the int only, because byte and short on the same level. Now, higher than int is a long, float, and double. Okay? This is the table we need for the higher. What it means? Govardhan, yeah, we are coming to that point only. We are coming to that point only. See now. Unary, I'll come back. I'll answer your question very shortly. Govardhan. See this only. What is the meaning of inter higher? Suppose very simple lab I'll take. Byte variable, guys. Byte B1 equals to 10 semicolon. Any mistake in this line? Any error in this line? I am declaring a byte variable B1, assigning a value 10 into that. Cool, right? Fine. Next. Byte B2 equals to 20. I am assigning 20 to another byte variable. Yes, 20 also in the byte range only, right? 20 is in the byte range. I can happily assign that. Very good. Next. Byte B3 equals to B1 plus B2. What is the output of this code, guys? $30, right? Anybody in the world can answer it. 10 plus 20 is 30. Very good. But this gives the compile time error. This gives the compile time error. Yes, Hari, you're right. Because, yes, even though 30 is in the range, here the key point, remember, everybody, listen carefully, guys. What is this? Byte. Byte plus byte, correct? You're doing arithmetic operation between two bytes. When you do arithmetic operation between two bytes, the result is, see the result box, whatever I written top, you see. Result box, what is the thumb rule, you remember? Result is always integer or higher than integer. So byte plus byte, the result it will not produce as, result is 30 only coming. Value 30 only coming. But the type of the result is integer. The result coming as integer here. Now integer higher, you are assigning to the byte B3. Can I assign the higher integer to byte? No. Incompatible types, possible lossy conversion from int to byte. That error will come in this line. So what do you understand? When you do arithmetic operation, the very crucial is 10 plus 20 is equals to 30. Any LKG student you ask, they will tell it. But the point here is byte plus byte. Result is integer type. Always the result integer will come or higher than integer will come. So first integer you understand. So if I do, you tell me these examples now. I am doing byte minus byte. What is the result, guys? What's the result of this operation? Integer only will come. Okay. Byte plus a short. Byte variable plus a short variable. Integer only. Int plus short. Integer only. Byte into short. Into operation. You do into multiplication or division. If it is arithmetic, if it is a binary arithmetic operator, byte and short participating, no problem. The result always the integer. Byte by int, for example, result is always the integer. Second, higher operation will understand. Int plus long. What is the result, guys? Int plus long. You understand, I think, why it is higher. It should be the long. So you understand higher. Why higher means if the operand type is int or any lower, it is the int. If any one operand is higher than int, then it is the higher. Now I'll take int plus float, guys. Int plus float is float only. Int plus double only. So it is taking higher part in this, right? Do you understand my result type? If the any one of the operand is integer or smaller than integer, result is int only. If any operand is higher than integer, the result is higher only. Clear? This is a very crucial point you have to learn now. Right? Now start the examples, guys. So first we'll do unary operator examples, then binary operator examples. Let's start the examples. What's the previous lab we had done? Part 2, last lab is 64 we have done, right? Now here we have to start with part 3. We have to start with 65 lab number. Okay. So first about unary arithmetic operators. How many unary arithmetic operators are there? How many unary arithmetic operators are there, guys? Just 2. What is the purpose of that? What is the purpose of that? To represent a sign, positive or negative. To represent a sign, positive or negative. Okay, you take first int a equals to something called 19, whatever number you want, plus or minus. Very good. To represent a sign, positive and negative. Next, int b equals to plus a, I am saying. Means the same a, positive value I am storing in b. Int c equals to minus a, I am using. Same a values, negative representation I am saving. Now I will print all these values. Or dot println of a. Very simple lab, I think. Now answer it. A19, it prints that. B19, positive 19 means, generally positive means we won't write. You can write, but when you're printing, it won't print it. Negative, we must say minus 19 like that. 19, 19, minus 19. Very good. Compile this program. Java C, lab 65.java. Compiled successfully and also executed. 19, 19, minus 19. Easy. Very easy. Very, very easy. So whether you understand my concept explained or not, you have to carefully answer now onwards. 66 lab. Byte a equals to 19. Byte b equals to plus a. Byte c equals to minus a. Print ABC. Tell me, guys. What I did is, because I am using a 19, right? 19 minus 19. For 19 is a small number. 19 is a small number. So why to allocate integer? Previous example, I declared integers, 4 bytes of memory. Why 4 bytes of memory for my small number integer? That's what I taken a byte. You tell me what happens. Poonam is telling error. Others not responded till now. What do you say, guys? Lakshmi is telling mine 1919 only. Alakya telling it will compile. Pavitra telling okay. Hari telling incompatible. Shekhar is telling error. Okay. Okay means what is Joshit? Okay means what? Okay. Let's do it, guys. Come on. 66 lab number. So half of you guys right. Half of you guys wrong. You know the answer, but incompatible types. At least decode the error. Why error came? I won't tell you. You only tell. It is telling incompatible types. Telling incompatible types. Possible as a conversion. Conversion from int to byte. Conversion from int to byte. Where this. What is the story I told till now? The story I told till now is result of arithmetic expression is result of arithmetic operator is arithmetic operation is int or higher than int. Result of arithmetic operation is int or higher than int. So plus is arithmetic operator or not? Plus arithmetic operator. When it is participated in any operation, plus minus, whether it is unary arithmetic operator or binary arithmetic operator, if it is arithmetic operator, when arithmetic operator is participated in any operation, the result is always int or higher than int. Plus a. What is the operand here? A is the byte. Okay, but the result coming up as integer. So plus a is producing as int and you are assigning int to byte again. So conversion int to byte. It is clearly telling int, right? What is the plus a result considered? Int only. Compiler also recognized as int only. That's what it is telling int to byte. I can't do this conversion. Result of arithmetic operation, guys. You see this, I written a box here. This is all explained the same thing. Do you understand the mistake you done? Very good. Come back now. So this is giving error. Why error is coming up? You understand. This is all you have to record, guys. Sometimes I may copy these errors here. Sometimes I may not copy. But when you do this compilation, all that you have to capture this so that you easily remember it later. So 66 is clear. Okay, error. Why error is coming up? We have a clarity now. 67 now. 67. Char ch1 equals to a semicolon. I am printing my char. Char, is that okay? No problem, right? Next. Char ch2 equals to plus ch1. And ch2 also I am print. Apply. Carefully apply, guys. Carefully think and answer it. Tell me what happens to the 67 I am doing here. Tell me, guys. Error incompatible. So you are aligned to the concept now. Plus operator is involved. plus character. The final result comes as int only. Int only. So, int higher, you are assigning to char, lower. Higher to lower, conversion problem. Incompatible types, possible lossy conversion from int to char. It has to give us int to char. Okay, ask the compiler whether we predicted the answer correctly or not. Wonderful, right? We are right. Same. It is telling now, see, conversion int to char. You are assigning int to char. So result considered as int. Previously, int to byte. The variable is byte, but the result is integer only. This also comparative error. So point is super clear. Very good. This causing the problem. Then, so what is the point to learn here is your errors you are learning. Next, corrections. Corrections means 68 if you do. 68. What is the key point to learn when you are working in the project is, suppose 68. You have a char variable, guys. Maybe you are doing some arithmetic operation here. So immediately what you have to realize, I am doing arithmetic operation with a char. Then result is coming as integer. So what you have to do, result always, you know the result type. My result comes here as integer. So I should store the result in the integer only, not in the char, correct? So the variable declaration, you don't do char. You know that it is not compare the char. You do. Clear? Now is this okay, guys? Is this okay now? Yes, this program will compile and gives. What's the output of this program? A and 65. CH1 means as a char it represents. But whenever you assign that to the integer, it will take its ASCII 65. A and 65. Very good. Plus 65, but plus means okay. 68 compiles and runs. Yeah, 65. Wonderful. One last lab about unary operator. This is also unary. 69 about the unary, guys. I am taking a double. Suppose d1 equals to 1234.56. My double value is there. I am thinking this program will compile and run successfully. What do you say, guys? Incompatible types, possible lossy conversion from where to where? Possible lossy conversion from double to int. Very good. That is the key you have to recognize. The result coming as a double only, right? Result is a double. You are assigning it to the integer. Double is the bigger. So this is the flow chart. Flow. You remember. Which is the smaller, which is the higher? I represented here. See, this is the box. You remember it. Which is the higher? Always the right side things are higher. Left side are smaller. Higher to lower conversion not possible. Automatically not possible. If you want, you can forcefully convert and do it. If you say, can I convert a double to integer, guys? Yes, forcefully you can convert. Normally, if you say convert, compiler will say, no, I won't convert because there is a loss of data in this. I won't convert. If you want, you convert it forcefully. That typecasting we'll see in the later sessions, right? This is the higher to lower, double to in, not possible, guys. So how to correct this program then? How to correct this program? 69A I am writing. 69A I am writing. The result we know as a double coming, so you declare always as like this. Oh. Is that clear? Yes. Which is 68 or 9, guys? 69. I think I didn't compile 69. Okay, compile and see the errors. Yes, 2 errors. Possible lossy conversion from double to int. See, error messages. Are you recording error messages, guys? You should record error messages, and I will ask you the count also. Till now, 69th lab it is. What are the errors? Unique errors. Some error will repeat multiple times, but you have to write down in separate book what are the errors coming up and the reasons. And you tell me in the next session, you tell me what is the error number. It may be a 12th error, 13th error, right? All has to get same number. I want to check that. So same, double to, possible consequence, double to int. Yes, we know this. Understand? These are the fundamentals, guys. You should be very strong on the fundamentals. Then only you will be called as Java expert. You should become Java expert. Yes. 69, yeah, I made everything as a double, so it works. So unary operators clear? Unary arithmetic, simple plus minus, we done all the experiments around this. Lab number 70. Binary arithmetic operators. So you learned half of the story already. Next time you won't do mistakes. I am assuming that you won't do any mistakes now onwards. Okay? So what are the binary arithmetic operators? What are the binary arithmetic, guys? 5 binary arithmetic operators. 5 operators. You no need to explain, I think, what is a plus doing, minus doing, right? You know about that. Let's play with them. 70. You know this. I already answered. Byte B1 equals to 10. Byte B2 equals to 20. This is 10. Byte B3 equals to 30. No, not 30. B1 plus B2. B1, B2, B3. So I am thinking this program will compile successfully and gives the output 10, 20, 30. What do you say? Error. Yes. Byte plus byte, the result is integer. Again, you are assigning integer to the byte, incompatible types, possible lossy conversion from int to byte. Compile time error. 70 compile time error. Very good. Right? Very good. How to correct this? So what is the key thing you are learning now? Whenever you're doing arithmetic operations, you see what type of result coming up. What type of result coming here? Integer result coming. So where I have to store that? I have to store the result in integer only. Yes, you declare int. You declare variable B3 also okay, or if you want to make a whatever. Int B3. Now, cool. This program will compile successfully and gives the output. This is the 71. Okay, compile successfully and giving us the respective output. Okay, now next. These are all small things to keep in mind. 72, guys. I have int. This is straight away I am giving error. Int a equals to something called 99 I am using. Or 1, 2, 3 semicolon. Byte b equals to a. and print A and B. I am not doing any arithmetic operation. That is what I want to confuse you here. I am not doing any arithmetic operation here. See carefully and tell me. Also, the previous points you have to remember. All combine here. Apply your knowledge and answer it, guys. Hari telling error. Sheikh also telling error. Pavitra, 1, 2, 3 error. Not possible, Pavitra, like that. If compile time error is coming, output will not come as 1, 2, 3 at all, right? Compilation failed means we can't run it. So, no option. Very good. Compile time error, most of you. Okay. Very good. You are assigning bytes. Whatever, same story, right? After result, integer coming. Can I assign integer to byte? That is the final story we land there. Correct? See, I am doing byte b equals to 10 plus 20, for example. Arithmetic operation coming, result coming something. But finally, where is the problem coming? The integer, assigning integer to the byte is the problem. Even though I am not doing arithmetic operation, you are assigning. The problematic statement is assignment operator actually. You can't assign integer to byte. That is the problem. So, compile time error, you understand it? Oh, very good. So, another tricky 73.java. Everything I am keeping same and just adding final to the variable. Now tell me, guys. Just added a final keyword for the variable A, remaining as it is. I changed the final, but the data type still is integer only, remember it. Data type still integer only, remember it. A is integer only. A is integer only. I am assigning integer to the byte. A is integer only. Only thing is, I made it as a final. It means I don't want to change that. I want to make it as a constant. A as a constant. I don't want to change. Fine. I'm not changing anywhere. So constant A, I'm assigning to B. Int assigning to byte. Int assigning to byte. Int assigning to byte. Durga is telling, very good. Hari, very good. Pankaj, very good. Durga, Hari, Pankaj got the points. See, that is how the learning is. You know that local variables, local final variables will be replaced by compiler, right? Yes or no? So what happens here? What is the compiler job? Can you tell? What is the compiler job? Can you tell how this will be optimized by compiler? These 4 lines, if you write in a source code, can you tell, guys, what compiler will do? What compiler will do first? Compiler changes. Wherever A is there, it will replace it, right? A occurrences will be replaced by the compiler. A is here, it is replacing. A is here, it is replacing. And the local variable, final local variable declaration statement will be removed. This is the statement. Now, in this, any compilation problem? Any compilation problem in this? This is the code I am writing. You are seeing on the screen. But first, the compiler translation happens like this. Do you have any problem in this? No. This program will compile and run successfully and gives the output as 123 and 123, right? You know the final variable point. You know about a final variable. You know that final variable occurrences will replace the values. But applying here in the right time is important. Now, as of now, we learned only very less core Java, guys. We learned so many points. Keep on, our points will add. These all points you have to remember in mind. When you're seeing a piece of code, maybe you have to apply all the points in whatever you know. That's what you have to read by heart each sentence. Say at the end of core Java, you know some 5,000 points. When you're seeing a piece of code, you have to search for 5,000 points. Now, as of now, you say you land 50 points. So now in the 50th, 1 point is the old final variable. That also you have to apply here. Keep on all the old concepts you have to apply. So please by heart each old sentence. Very good. 3 guys got the sense of this. Fine. So this program will compile or not? It will compile, guys. 73, I am compiling. Very good. Compiler also accepted. Output is 103, 103. Do you want to see the decompilation? 73 dot class. Can we have a look on decompilation? You should think like a compiler, guys. Your mind should become like a Java compiler. Maybe super better than Java compiler. Decompile. This is the statement. Part 3, 73. Is this fine? See, I'm copying what they done. Is that what we predicted? That's the output, guys. Fine. So it's compiling. Now you add another point. You see this also carefully. 73 done. 74 now. 74. Final byte B1 equals to 90. Oh, this is byte, guys. BYTE. Final byte B2 equals to 9 only. Okay. Final byte B1 equals to this. Final byte this. Byte B3 equals to B1 plus B2. B1 plus B2. Careful. Think. You have to think carefully but fastly. Your brain has to work like compiler. Now you answer it. Abhishek is telling, Navin is telling 2 finals. Why 2 finals? What's the problem to you? I can declare 1,000 final variables. Constants, I can take anything, Navin, my wish. In my program, I can declare any number of variables, right? Navin, how many variables I can declare in the program? I can declare many variables. Similarly, constants or final variables also you can declare n number, no issue. So most of you are running behind error only. Most of you telling error only. Anybody says this will compile and run? Anyone? This will say compile and run? Pavani telling run. Hari is telling. Abhishek is telling. Pankaj is telling it will compile. So what is your compile means why you are thinking it will compile? Error, so many are telling error. Why you 3 guys, 4 guys telling yes? Why it can? Tell me the reason why it goes, guys. Again, it is a final game, right? Local final, what happens, guys? See, the translation happens here. Let me to compile and run, I'll tell you. Now, other guys who told error, can you, I'm giving option to rethink and tell me. Any chance to get this compiled? Oh, it's compiled successfully, guys. Why you told error? Any reason why you told error? This is the final, very good. What is optimization of the compiler changes now? Wherever B1 is there, replaced with 90. Okay, here B1 occurrence 1 time, replace 90. B1 occurrence 1 time, replace 90. Then B1 declaration remove. Next take B2, whose value 9. B2 occurrence one time, replace. B3 occurrence one time, replace. Then remove the B2 declaration. And here, this is 90 plus 9 is a constant, right? This is a constant. Constant operations will be evaluated. Constant expressions will be evaluated by the compiler. These are all sentences I told. Constant expressions will be evaluated by the compiler. It makes 99. So your program becomes like this, guys. Where is the byte and byte, Pavitra? It will do checking, grammar checking next level. See, first final variable replacement happening. This is the code. In this code, any errors are there? First, the final replacements has to happen, Pavitra. First, final replacements. I done that. Then now check the syntax errors. Do you have any syntax errors in this code? Do you understand, guys? See, in your program, whenever a local finals are there, immediately first remove the local final declarations and replace the occurrences. Then you see whatever the story is there. First, if you compile, you will get the problem. B1 plus B2. First, it won't compile. First, replacements will happen. This code will be converted to this first. Then it will compile this, checks the errors in this piece of code. Byte B3 99 you declared actually. No problem. Printing 90 constant value, printing 9 constant value, printing B3 99. This is the code it is compiling. Understand, guys? Who told error? Point is clear. Very good. Compile this. Compilation done, I think already. Yeah, we'll ask the decompiler whether our assumption is right or wrong. We have online decompiler, which is a free only. Just go 74.class file, upload and check whether I am right. This is there in the bytecode, guys. This only there in the bytecode. This only there in the bytecode. This is not going to cause any problem. Is that clear, my dear students? Next tricky. Get ready. 75. 75, guys. Pooja is telling not yet clear. What is not clear, Pooja? What do you understand about the final variables, Pooja? Do you understand about the final variables? Tell me. So here is the final variable, right? This is the code actually. How the final variables workings, I think you did not practice, Pooja, but anyway, I am telling again, please listen carefully. What happens when a final variable is found? And final also local final, very clearly remember it. Not all the finals. Instance final, static final will not be removed, remember it. Local final found, what happens? Two things will happen. First, then compilation. Pooja, first it will not compile. First final variable related work will be done. B1 is the final variable. What compiler will do first? Whenever B1 is found, now compiler, B1 occurrences will be replaced with the B1 value. B1 occurrences means wherever B1 is found. How many times B1 is found, Pooja? This is the one B1, put 90 here. This is the one B1, put 90 here. Done. So all occurrences replaced. Then remove the B1 declaration, gone. We don't have B1 variable at all. Next, another final I got, whose value 9. So B2 occurrences again 2 times. Here is the 9. Here is the 9. Done. Then B2 declaration will be removed. Now see, 90 plus 9. What is this? Is this an arithmetic expression? 90 plus 9 is arithmetic expression. Am I right? Yes or no? Yes. My question to you, who will evaluate this? Compiler will do or JVM will do is a question mark. Who will do that? Compiler only telling. Why compiler will do? Generally execution all JVM has to do, right? Why compiler is doing? Pooja, Pavitra, tell me why compiler is doing? Because it is a constant expression. What is the meaning of constant expression? You know the constant expressions, variable expressions. This also I told. When you take 2a plus 3b equals to 9. In this, what are the constants? 2 is a constant, 3 is a constant, 9 is a constant. What are the variables? Variables means whose value will be changed. And constants means whose value is fixed. 2 fixed. Expression 2 will not change, right? Now, this is a constant. Constant means value will be changed anytime at runtime. There is no point, there is no chance to change this value at runtime also. So what compiler is doing, now only finishing it, so that your execution time will reduce later. Compiler only evaluating the 9 plus 90 plus 9, compiler only replacing the result as 99 here. Okay, guys. Now it will check for a grammatical mistakes. Do you have any grammatical mistakes in this, Pooja? No objection. That's what compiler test is passed. Is that clear? So you have to read all the older topics carefully, guys. You have to spend a quality time to read all the older topics. Okay, that's fine. So where we are now, 75 we are taking. Byte B1 equals to 95. Byte B1 equals to 90. Byte B2 equals to 38, guys. 38. Byte B3 equals B1 plus B2, printing all this. I just change the values. I think easily you can answer it. But think carefully and answer it. Easily you can answer, but think carefully and answer. 75. Hari is telling error. Abhishek error. Srinivaslu error. Why error? Sum is 128. Yes, small number is extra. Here is the problem. Now do like a compiler. First do like a compiler, guys. Do like a compiler. Where is the problem coming? You see. Do like compiler. First B1 is a final variable whose value 90. Because B1 is a local final, B1 occurrences will be replaced with all. B1 occurred 2 times. B1 is here, B1 is here. Done. Then B1 declaration remove. Next we have another B2 variable of byte final only. B2 occurrence also replaced with the value 38. Done. 2 occurrences done. Now B2 declaration remove. Now 90 plus 38 is a constant expression, right? This is a constant expression. So it will do the operation. Value will come as a 128. This is the problematic. Can I assign 128? What we discussed? When you are assigning a value to byte, minus 128 to 127, if you assign, it will consider as a byte and assigns. Beyond that, the number will be considered as again integer only. Am I right? If I take int 128, which is the out of byte range, so this will not be considered as a short. This will not be considered as a short. This will be considered as int only because default type is int. Now you are assigning into to byte, guys. Into to byte, if you assign the story, you know, right? So what happens? Now compiler will see 120 you are assigning, which is not possible. 75, compile it. See, incompatible types, possible lossy conversion from int to byte. You can't do that. So previous lab and this lab are very close. You cannot assign to short also. Is this okay? Can I do this as like this? You tell me. If I do this, is that okay, guys? Instead of byte, I am assigning to short. Is that okay? Pankaj asking, can I assign to short? Is that okay? Tell me, guys. Now what happens? Right? Now, you are assigning 128 to the short. When you are assigning value to short, what it will do? Within the short range, it takes. Beyond the short range, it will consider as integer. I think these points I have typed in some program also. I don't know whether you are recording the points or not. In one of the lab, I typed this. If I remember which lab it is, how to check in this many number of labs, which lab I typed. Oh, not bytes. Yes, lab number 44. See, guys, when you assign a values to the byte variables in the range of -128 to 127, those will be considered as a byte. Beyond the range will be considered as int. When you assign the values to the short variables in the range of this, then those will consider as short. Beyond that, consider as int. Now, if I declare a variable as a short, you are assigning 128 to the short. Can I assign 128 to the short? 128 is in the range of short. 128 is in that range of short. Yes. So compilation okay or not? Okay. Have you taken these points? Have you taken these all not there in booklet? If I want to add all this in booklet and we'll add so many points, in that case, our core job only will take 1 year of time. You should take each point I'm recording, guys. Some will be there in booklet, some will not be there. 44. Okay, guys. That's what it is done, right? Short means fine. Very good. 75 is done. 76, guys. 76. Final long A equals to 12. Final long A equals to 12. Then I'm saying byte B equals to A. Print A and B. Very simple lab, it seems. Think carefully, answer it. See it and tell me. What happens when I compile lab number 76? Most of you are thinking it will compile and run. Okay, wonderful, guys. 12 and 12 is the output. Harishankar is opposite, telling error. Why error? Harishankar and Malik, Bhargav. Incompatible types. Where is the problem? Why so? 12, right? Okay, you do the decompilation. Anyway, it is giving error, but we will still we see. You do like compiler. That compiler is giving error. You do like your compiler mind, your mind as a compiler. Tell me, I have a final variable, right? I have a final local variable. What I have to do? Final variable is there means. What are the final variable is there, guys? For A variable, for A is a local final. A occurrences has to be replaced with the values. A value 12. So where A how many times occurred? One time A replace, second time A replace. After that, A variable declaration you remove. Then what is the problem in this code? What's the problem in this code, guys? Why it is telling error actually? Why it is telling the error? And if you read the error, it is telling possible logic conversion from long to int. It means what? It means the 12 considered as long. How? 12 is in the byte range or not? Yes. Then I can assign to the byte. 123 also assigned. What's the problem with the 12? Why it is considering 12 as a long? That is the compiler is telling error. When we do that, it is okay. But something difference between our compiler and Java compiler. Where is the conflict? See the key point now, guys. What happens is, I'll redo this again. Same thing, I'll redo like this. Okay. See here, A is a long, right? A is a long value. Now, for long values, any suffix or prefix or something is there? What is there? LS suffix, right? Yes. Here is the point. What happens? What compiler will do is, first, because it is a long value, whenever you assign a value to long, immediately, value can be 12 or whatever, small or big, immediately it will add ls suffix. First step, extra step this is, when a long value, whenever you assign a value to the long variable, the value will be suffixed with L. So what is A value now? What is A value, guys? A is 12L, 12 long. Now final variable. Now final variable occurrences has to replaced. You please replace and then remove the final variable. Now tell me, guys, do you understand why our Java compiler is giving an error? 12L is a long value. 12L is a long value. You are assigning clearly, super clearly, you are assigning long to the bytes, which is not okay. Go to the error message. Why it is telling long to byte error? This is the reason. Okay. That's the, okay, guys. So 76. So still we have, these are all simple arithmetic related only, but other, all are not arithmetic. I'm just doing surrounding extra points also adding in this only. In this actually no arithmetic operation, right? So we are doing extra, we are learning more on this. Fine. So I think still we have arithmetic operators. After finishing arithmetic, we will go for string concatenation. We'll do in the next session, guys. In the next session, we'll finish the remaining labs of arithmetic, plus we'll learn string concatenation operator in the next session. Okay.